All right, everyone, fourth unit. So here we go. Promised you way back in chapter 2 when we started our first set of basic graphs that there would be more fun and more basic graphs. So today you're gonna have your next 2 basic graphs that you're gonna add to your repertoire. And so we are gonna talk about rational functions. That is the topic of all of chapter 5 that we're going to talk about, rational functions. So first thing I need to do is I need to tell you what a rational function is so that we can all be speaking the same lingo. So the definition of a rational function: it's a function that is in the following form. Okay, so it is f of x is equal to, and since it has the word rational, you're probably expecting a fraction because rational numbers. So it is going to have a polynomial of some sort in the numerator and then a polynomial of some sort in the denominator. So the typical way that this is presented to us is p of x divided by q of x. And I'm going to let you know where both p of x and q of x are polynomials. And the only thing that we have that limits us, it's going to make our discussion up till now, we haven't really talked a whole lot about anything fun with the domain. That is going to change in this chapter. And so the thing that's going to impact us is q of x cannot have an output of 0. Can't have 0 in the denominator. So there's your definition. Okay. Pretty relaxed, pretty straightforward. Just going to repeat it for those of you just getting acclimated to being here, that our rational function is a function that is the form of something with a polynomial in the numerator, polynomial in the denominator. What that means is all of our exponents are going to be whole numbers. We will not have any negative exponents. We will not have any fractions involving our variables in either the numerator and denominator, and the denominator can't be 0. Okay, so that is the definition. So what we're going to start is with our two basic rational functions. Then we're going to go on from there. So the first one is called the reciprocal function. This is as simple a rational function as you can possibly have. It is the function 1 over x. It's our basic function, so we are going to learn how to deal with this. So I'm going to come over to the side. I should have probably designed this sheet a little better. I apologize. I'm going to make a little XY table over here on the side. And we're going to put some values in here so that we can figure out what the shape of this graph is. We're doing the same thing here that we did in chapter 2 when we did the shape of the quadratic function and the cubic function and the identity function. We've been through this process before. So I'm going to pick the x values just to kind of help us out. So these are the ones I'm going to pick: 2 and 1, and then I'm going to pick a fraction, pick a half. We're going to plug in 0. Then we're going to do the negatives of all these. And then we're going to see what happens, if we can see what the general shape of the reciprocal function is going to be. Okay, so for the first few, when I plug in 2, when I plug in the value 2 into my reciprocal function, my 1 over x, what do I get when I plug in, what's f of 2? What does that become? Where am I putting the 2? In the denominator, so it's going to be 1/2. Fantastic, great job. I'm not going to write them all out like that, but I just wanted to see. All this is saying is whatever x value you're putting in, you're sticking in the denominator. Okay, so when I plug in 2, that means I have a 2 in the denominator, so I have 1/2. When I plug in 1, that means I have a 1 in the denominator. So what is the output value? 1 over 1. Yeah, fantastic. You're doing great. Love it. This is probably the most difficult one the first time around when I put a 1/2 in the denominator. So let me write this down. I'll write it down right up here, making kind of a big mess of my page. Sorry about that. When I put a 1/2 in the denominator, what's the reciprocal of a 1/2? What happens then? I'm sorry, I just didn't hear what you said. Perfect. When you put a 1/2 in the denominator, you flip it over and it becomes the value 2. That's why this is called the reciprocal function. If you need verification of that in your calculator, do 1 divided by 0.5. Okay, 1 divided by 0.5 is going to give you 2. So that's the reciprocal. Oh, here's the fun one. When I put 0 in the denominator, what happens? What was that? No, no, no. Oh, no, it's not 0. You can't, dividing by 0. Oh, yes, let's always remember. Okay, let's just go back. I know arithmetic class was long, long ago in a galaxy far, far away, but I just want to make sure we understand the difference between these two things. If you have 0 of something and you want to divide it into any sort of groups, one group, let me set up this division. If I have 0 and I'm going to divide it by 1, well, what number up here, when I multiply by 1, is going to give me 0? 0. Okay, so when you have 0 in the numerator, that's equal to 0. When you have 0 in the denominator, let's set this up as a division. I'm going to take 1 and I'm going to divide it by 0. Now the 0 is on the outside. What number up here, when I multiply by 0, is going to give me 1? There's no such number. No big number, no small number, because anything you put up here, whatever value you put up here times 0 is always going to give you what? 0. Okay, so there's no such number. Okay. And so what we say when we divide by 0 is we call that undefined. Yes, I knew that was going to be interesting. We always make that mistake, and I understand it. We just kind of get lulled to sleep. So I'm just going to put UND there just because I don't have a lot of room, but that stands for undefined. Can't put 0 in the denominator of a fraction. So going back to my definition, that's what this means right here. My rational function is my polynomial p divided by my polynomial q, and the polynomial q can't be 0. Okay, can never have the output 0. We'll talk more about that. That's going to be a big deal. Did everybody get our sheet that we're working on or writing on? If you didn't, it's right up here at that front desk. As you walked in, I just haven't been paying attention. Apologize. All right, let's see. If I do the reciprocal of -1/2, what's the reciprocal of -1/2 going to be? -2. Indeed, that is true. Great. What's the, when I put -1 in the denominator of my fraction, what's the reciprocal of -1? I think I heard you say -1, but there's this wind blowing in my ear right here. And then -2, when you put -2 in the denominator of the fraction, what's the reciprocal of -2? -1/2. Anyone not seeing where these values are coming from? Because if you see where the values are coming from, even if you don't remember the general shape of this, when on the test, when you go to reproduce it, and I'm going to give you the same advice I've been giving you with all the other basic functions, practice this a few times. Okay, it's going to be a big part of the next test, you being able to reproduce this. Okay, so just like it has on other ones. So here we go. I'm going to plot these points. The first one is 2 and then 1/2. 1/2 is just going to be a little bit between 0 and 1. So I'm just going to make a dot right there. And then a 1, 1, and then 1/2, and then up 2. You could put in other values, but I just don't want to make a big mess. If I put in 3, I'd get a 1/3. If I put in a 1/3, I'd get 3. So you can kind of see what's going on. 0 is undefined. Whenever we have something undefined on our graph, what we are going to put is what's called it's called an asymptote. We're going to talk a lot more about asymptotes. And so what it is, all an asymptote is just a little dotted line. It's like a force field if you're a fan of Star Wars. Okay, so this is called a vertical asymptote. Asymptote is my second favorite math word to say. So there you go. We'll talk a little bit more about that in just a second, because that's a super important part of this graph. On the other side, we go to -1/2 and -2. So I'll make a dot right there. -1 and -1, and then -2 and -1/2. And there's my thing. So what's going to happen here is I connect these dots. Since my graph is undefined here at x equal to 0, that's a force field. No graph ever that we talk about in all of chapter 5 will ever go through a vertical asymptote. It's impossible. Okay, so what my graph's going to do as I go this way is it's going to get closer and closer to asymptote, and it's just going to keep going up and up and up. I'm going to put a little arrow. Now this particular problem, let's just think about this. If I took the reciprocal of 10, what's 1 over 10? As a decimal, what is that? It's 0.1, right? But it's a value, right? Let's go out further. Let's say my graph was big enough and I could go out to 100, like way out, way out here. What's 1 over 100? What's that as a decimal? 0.01, right? But it's still a value, right? So I could keep doing that. What's 1 over 1,000,000? Well, 1 over 1,000,000 is 0.00001. Some number of zeros and a 1. It's always a value. So this graph is never going to hit the x-axis. It's going to be like a plane that gets closer and closer and closer, but will never land. Okay, so what I'm going to do is I'm just going to draw. I'm going to extend it a little bit. I'm not going to go too far because my pen's kind of thick, but that graph will never go through the x-axis. So because of that, this graph right here also has what's called a horizontal asymptote. So I'm going to draw a dotted line. Not all of our graphs will have horizontal asymptotes, but this one does. And then the same thing is true on the other side of the graph is as we connect these dots, as we get closer and closer to the x-axis, the graph is just going to get closer and closer. It never goes through it. And then the same thing with the x-axis here. It never gets any closer. So our basic graph, this is called, you don't need to remember this. This is just bonus content for the day. This is called a hyperbola. Okay, and the asymptotes on the hyperbola are super important because they define the behavior of the graph. And that when we get to section 5.2, that's going to be part of our general process to graphing these things, is we are going to find the asymptotes first because they tell us how the graph is always going to behave. So here's what I would like you to do, because I know that this is probably for most of you new and different. First time you graph the parabola, I would guess. So what I would like you to do before we worry about exercise 1, graphing 1 over x plus 3, we'll talk about the plus 3 in a minute. What I would like you to do is take a moment and reproduce for yourself the basic graph of 1 over x on here, and then we'll do the plus 3 part of it. Okay, so you're reproducing the basic graph of 1 over x on this Cartesian plane right here, please. Whether you need to go back and reproduce the whole table, or whether you understand the table and you just need to plot and draw the graph, whatever you need to do, please do it. Bless you. Okay, so I'm just going to start plotting these points. The things that I want you to practice as you are reconstructing this graph. The most common mistake students will make when they're doing this is they'll get a little, I don't know what to call it, a little crazy with the ends of this. Okay, so your ends here, do not bring the graph down under the axis. Okay, I'm trying to be very specific with you that the asymptotes define the behavior of the graph. Okay, so I'm just going to be real careful and cautious and just going to extend it a little bit here. I'm not going to get too enthusiastic. And there we go. Now, before we do that 1 over x plus 3, which is the new part to this problem, and well, it's actually not new, it's just using the stuff we talked about in chapter 2. Before we do that, let's go back over here to my reciprocal function graph. Let's talk about the domain and the range of it. The domain are my x values, looking left and right. So there's one x value that causes me a problem as I go left and right. What is that x value that I'm having a problem with? 0. So what we need to do in our domain is we need to let everybody know that's reading this that we have to hop over the x value 0. So the way we do this, I think we've done this before in this class, but just in case we haven't, remember negative infinity to positive infinity. But what I have to do in the middle is I have to hop over 0. So I'm going to put a comma 0 on this side and a parenthesis. That tells me it's not going to be equal to 0. Union, another parenthesis, 0 to infinity. So what that domain says is it's everything to the left of 0. It's everything to the right of 0, just not 0. Don't use brackets. That would be a big mistake because a bracket means equality. You would be including 0, and then you're communicating something different. The range is the same thing. As I look up and down, I've got this horizontal asymptote that my graph is getting closer to, but it never goes through. So the range is the same thing. So aside from the square root function, this is the first time that we've had a function that has kind of a fun and interesting domain. So that's good. So before I have you do this graph, I want you to tell me, when I have a +3 off to the side of my function, what is happening to the graph? Up 3. Yes, we are adding it to the y value. The same thing's happening to this graph as when we did, just as a blast from the past, when we did x squared + 3 or x cubed + 3. When the +3 is outside of the function, that's y movement. So that's translating up. So what I would like you to do is practice, translate this whole graph up. My recommendation is start with that horizontal asymptote and move that horizontal asymptote up 3 and then go from there. Give it your best shot. We're learning. So what my hope is it's not too big of a deal to move all. The big deal here is we've got this new basic function. I'm hoping it's not too big of a deal to move these points now up 3. Because the asymptotes define the behavior of the graph, I like to start with those. Since we've moved the graph up 3, my vertical asymptote does not change. So I'm just going to make my ... right here. The horizontal asymptote, though, is going to go up 3 units. So that is going to be right here. So ... And now all these points just go up 3. So instead of being at 2, this one's going to be at is going to be 1, 2, 3. It's going to be at 5. Instead of being at 1, 1, 2, 3, it's going to be at 4. Instead of being at a half, it's going to be a 1, 2, 3.5. There is the right side of this graph right here. And again, I'm not going to overextend these because then, then bad things happen. We're just doing a cute little sketch. It doesn't have to be. It doesn't have to, take up the whole Cartesian plane. Same thing over here. When I do a half, we go 1, 2, 3. And then 1, 2, 3, and then the final one's it's at -2, 1, 2, 3 goes to 1, and this is my graph right here. I know this is new. I know this is difficult. Does anyone have a question that I can help clarify anything for you? All right, then here's what I would like you to do. Exercise 2. We've got a slightly different format of our reciprocal function. This time the -4 is in a different place. So do 2 things. First, practice the basic graph again. Do it maybe real light or dotted, and then use that basic graph to figure out what does that -4, what is it doing to the graph when it is there attached to the x. just so that we're all going in the same direction. I'm not going to work the problem yet. This -4 down here attached to the x, what have we learned that that does to my function? What's that? To the right. Yep, it's going to the right 4 units. Okay, when you do your adding and subtracting right to the x, you're moving the function left and right. Right, so hopefully everybody still has the table of values on your paper. And so the first step to this, as you're getting used to this new function, is just take that table of values that we've already done once, twice, and put that table of values right here and reproduce the basic function. Step 1. Okay, that's going to help you get used to where these points are. So if you had no idea what to do, that's step 1. Step 2 is now going back to what we learned a while ago about behavior of functions and translations. This -4, it's in a different place than the +3 was up here. So I hope you can see the difference. Okay, this +3 is off to the side. That's what tells me it's going in the y direction. This -4 is right on the x. That tells me it's the left and right decision. So since it's x -4, that tells me to go right 4. So now I'm ready. I'm just going to take this graph and I'm going to move everything to the right 4. So that means that my vertical asymptote is going to go to the right 4 units. So I'm just going to make a nice dotted line right here, 4 units to the right. My horizontal asymptote, since we've gone right 4, does not move at all. So I'm going to just nice and green right here on the x-axis. And then each of these points, I'm not expecting you to recalculate anything. The reason I want you to reproduce the basic graph first is now just count 4 units to the right. That's all I want you to do. Okay, so 4 units to the right. 1, 2, 3, 4. I'm going to make a dot. 1, 2, 3, 4, make a dot. And then 1, 2, 3, 4, make a dot. And here is the right part of the graph right here. The left part of the graph, 1, 2, 3, 4. 1, 2, 3, 4. And then finally, 1, 2, 3, 4. And here is the other part. Just being careful. The biggest thing I look for, in all honesty, is that you are letting the asymptotes define the behavior of the graph. Don't go through the asymptotes. Okay, use it to form the shape of your graph with those basic points. So we're going to do another one. I know, it's amazing. So here's the next one, exercise 3. Now I'm just having you do both translations. So again, step 1, reproduce the points. What I'm going to do is I'm going to bring down that table in case you forgot to copy it into your notes. Reproduce the points for the basic graph and shade it real light, and then do the translation that I've asked you to do in exercise 3. Just again, so we're all doing the same thing. I'm going to give you another 90 seconds or so. What two things are happening to this graph? It's going left 2, I heard, yes. And then what other thing? Oh, excellent. Great job. Okay, great. So I'm going to move the whole thing left 2 and down 4. So first thing is I'm going to see the impact on the asymptotes. So I'm going to move that vertical asymptote left 2. So it's going to go right here, left 2. Then I'm going to move the horizontal asymptote down 4. So right here. So almost looks like a whole new X and Y axis down there. And now I'm just going to move each point left 2 down 4. So left 2 and then down 4, left 2 down 4, and then finally left 2 down 4. And there is the first part of the graph right there. And then the other part, left 2 down 4, and then left 2 down 4, and last but not least, left 2 down 4, and there's my other part. Okay, again, I know, new and different, difficult. Rational functions, I get it. These are not our favorite things to work with. Before we flip the page, if there's a question, ask it, please be sure. I know it's Wednesday, you can't wait to get out of here. We're halfway done with our semester after today, so congratulations. What I would like you to do for each of the exercises we just did is I would like you to write down what is the domain and the range of each of them. Okay, so what's the domain and the range? Taking into account our translations. All right, so the first one, example 1, or to exercise 1, we moved it up 3. So it has not been moved left or right at all, and you can see that from the picture. So the domain stays negative infinity to 0, union 0 to infinity. We still have that vertical asymptote right there in the middle of the graph. The range, since I slid the whole graph up 3, the range changes slightly. So we have negative infinity all the way up to that horizontal asymptote of 3, and then union 3 to infinity. So that is the first one, domain and range. Exercise 2. Exercise 2, instead of going up, we moved this one to the right. So in this one, it's the domain that's going to change because we moved that vertical asymptote. This time, what's the value that I have to skip in my domain? 4, indeed. So negative infinity to 4, union 4 to infinity, great. And then the range, the range is how far up and down. Well, I haven't moved that one at all. And so the range is negative infinity to 0, union 0 to infinity. And then our most recent problem, exercise 3, we've done both things to this one. So the domain, I've moved it left and right. You can see the vertical asymptote has moved left 2. So that means my domain is negative infinity to negative 2. And then negative 2 to infinity. And then the same thing for my range. My range, how far down have I moved this? Well, down 4. So that means my range is negative infinity to negative 4, union negative 4 to infinity. I'm going to flip the page unless there is question, unless I have cause to answer. I would love to answer a question if you have it. Please don't sit there mutely and not understand something and think it'll click into place. Maybe it will when you do some homework, but I would love the opportunity to answer questions. Okay, one more with the reciprocal function, and then we'll talk about our other basic function. And if you can work with the reciprocal, you can work with the other one. So this one, again, first thing I would like you to do on exercise 4 is reproduce the basic graph using the table that we have. And then instead of a 1 in the top, I've got a negative 2. So I've multiplied by something here. So how is that going to impact the graph? So good luck. Give it a try. Again, just a nudge. This negative 2 in the top. What am I going to do to my function here? What does that do? Give a hypothesis. It's going to flip because it's negative, and then what else we're going to do with it? Multiply by what? Yeah, so basically what we're doing is we're multiplying every y value by negative 2. Okay, which is going to flip it as I was told, and then it's going to double the y values. So this one, because it's instead of a 1 in the top, it's a negative 2. That means we're going to multiply all our y values by negative 2. Great. Okay, so I'm going to multiply all these y values by -2. That does not do anything to my asymptotes. So I just, I put some hopefully sort of subtle dotted lines in there. And now I'm going to multiply the y values by -2. I'm just going to start with the right side of the graph here. So this y value is already 2. So 2 times -2 becomes -4. So I'm going to make a dot at -4. The y value of this point is 1. So 1 times -2 is -2. So I'm going to make a dot right there. And then the y value of this point is a half. And you can use your calculator. A half is 0.5. 0.5 times -2 is -1. So here is the right part of this graph. It's stretched out. I totally missed that dot. Sorry, that's bad math professor. On the other side, the y values, this one right here is a y value of -2. So -2 times -2 is +4. This one's -1. So -1 times -2 is +2. And then finally, -0.5, -0.5 times -2 is +1. And here's the other side. So it's been flipped as I was told. That was great observation. And then all of the y values have been doubled in addition to their sign being changed. So there is my graph. Not going to worry about the domain and the range of that. We settled that on the front part of this. If there's no questions about the reciprocal function, we're going to move on to the other thing from section 5.1, which is the square of the reciprocal function. Yeah. Can I what? Right here? The table for the new graph? Okay, so what I would do then, so just in pencil here on the side, what I would do is I would say this. Okay, here's my old table. 2, 1, yeah, a half, 0, -0.5, -1, -2. Okay, so that's the old table, and so these are the old values. So when I do the reciprocal of this, I get a half. When I do the reciprocal of this, 1, 2, this is undefined. This is -2, -1, -0.5. None of that, I've not reproduced anything different. The reason I would do that is then I would say, okay, in this particular problem, we're not changing any of the x values because it's been multiplied. So the y values. So what I've got is -2 times y. Okay, and so I would just use your calculator, -2 times y. So -2 times a half is going to be -1. -2 times 1 is -2. -2 times 2 is -4. -2 times undefined is still undefined. -2 times -2 is 4. -2 times -1 is 2. And then finally 1. Does that make sense? Is that better? Yeah. Did I mess something up? Okay, yeah, sure.
Should we always start off with the first, like, first one in this, and then draw like when we plug in the other one?
I would say the reason that what I would do, my process, if I were you learning this, first day learning this, first day seeing the hyperbola, I would every time I would draw the basic graph right here from the original table. And then now you can rely on what we've hopefully learned up to this point is what do these transformations do? And I've just reviewed the different transformations we've seen with our other graphs, our x squared and square root and all that stuff. And so that's why I said, okay, this says multiply the y values by -2. So here are the y values of the graph that's in pencil. And this is me just multiplying all of them by -2 and redoing. Yeah.
So like the very first value of the x's, and then the very last value of the y.
Right, exactly, yeah. My x's did not change in this. I've not done anything in the x direction. So yeah, I'm still using the x's and then the y. And remember, if you did have a problem that combined the multiplication and doing something in the x's, my advice to you has always been do the multiplication first. So create the stretching graph first, and then you can slide it around with the translations. Don't do everything at once. It's too much. I wouldn't even do that. Okay, I would do the stretching first and then translating. Okay. Any other questions? Great questions. I love it. You're processing. Thank you for asking questions. All right, the reciprocal square function, super similar. So I'm going to create a table again. we're going to use the same x values we did before. So this is our basic function right here. 2, 1, a half, 0, negative a half, negative 1, negative 2. So now not only are we doing the reciprocal, we're also squaring. That's why there's an x squared in the bottom. That's why it's called the reciprocal square. You're doing both things. You're flipping and squaring. So for 2, what do I get with 2 when I flip it and square it? What's that? Not 1. Well, first, what do I get when I flip 2? What's the reciprocal 2? A half. And then what's a half squared? Okay. Oh, multiplying fractions. Don't overcomplicate this. Multiplying is supposed to be the one operation that's our friend. Okay, so multiplying, you just go straight across tops and bottoms. 1 times 1 is 1, 2 times 2 is 4. Okay, you guys were adding accidentally. I get it. We hate fractions. Multiplying, you multiply tops, you multiply the bottoms. Okay, so when I do the reciprocal of 2, I get a half, and when I square it, I get 1/4. The number 1, yes. Okay, square it first. When you square 2, you get 4, and then the reciprocal of 4 is a 4th. Either way you want to do it, it's going to work out the same way. Perfect. Okay, so 1, when I do the reciprocal of 1, it's still 1, and 1 squared is 1, almost as good as working with 0. A half, what's the reciprocal of a half? 2 over 1, and then you square that, and you get 4. Great. 0, what's the reciprocal of 0? Yes, thank you. Undefined. That's what we saw last time. Again, negative a half. What's the reciprocal of negative a half? When I flip it, I get negative 2. I heard somebody say, I got a winner. Negative 2. And what's negative 2 squared? We end up with positive 4. Remember, we're squaring, so everything's going to end up being positive. Negative 1, the reciprocal of negative 1, again, is negative 1, and I square it, 1. And then finally, what's the reciprocal of negative 2? Negative 1/2, yes, and then negative a half times negative a half is going to be positive a 4th. So this is a similar graph to the other one with one key change. So when I go over 2, I go up a 4th. So we're just kind of right there, right above the x-axis. 1, 1, a half goes up 4. So you can see it's moving quicker. It's still never going to hit that horizontal asymptote. It's still never going to hit that vertical asymptote. On the other side, though, instead of being down below the x-axis, my negative a half, when I square it, it became 4. So it's positive. And the negative 1, when I squared it, it was 1. And the negative 2, when I squared it, became a 4th. So it, too, is above the x-axis. If you're familiar with old school video games, it looks like the Atari symbol to me. I'm a child of the 80s, so that's how I learned to play video games. That's why I'm bad at modern video games. Okay, so there we go. That is our reciprocal square function. So domain and range. Domain is absolutely no different than the other reciprocal functions. So I'm just going to write it in here, and then you're going to help me with the range because it is different. What's the low boundary of the y values? How far down does that go? 0. Yep. And I'm going to put parenthesis there because it never goes through that. And then it goes up pretty clearly. It goes up forever, really fast to infinity. One other bit of trivia about these two graphs before I have you finish out and do the final 2 examples on this page. What's the symmetry of this graph? Is this even or odd? Another blast from the past. I know I keep bringing back all this stuff we did previous units. Somebody said it though. It's what? Even. Yeah, it's symmetric about the y-axis if I fold it. So the reciprocal square function, this is an even function. I'm going to flip back over to the front page because I meant to mention it at the time. Our reciprocal function. Well, it's not even. It's not. I can't fold it along the y-axis. But what is the reciprocal function? Yeah, remember the test for odd, the visual test is if I hold my pen at the origin and I twirl the graph. Oh, look at that. It's the same shape. So that's odd. It's symmetric about the origin. Okay, so these two graphs kind of fit in with other things that we've talked about so far in the first half of this semester. So, exercise 5. What I would like you to do is what we were doing before. I'm going to leave the table of values right here in case you did not copy it down on your notes. First thing I would like you to do in exercise 5 is reproduce the basic graph. Then, what does that -5 do to that basic graph? I'll give you a minute or two to do that. Just a nudge, once you've done the basic graph, what does that -5, what is it going to do to my graph? That's exactly correct, down 5. Great job. And just for this one, we're not going to do it for both final ones. Write down the domain and the range. That'll be the last thing from this particular example that we're doing. Domain and the range afterward. All right, so here's my basic graph. I got it in pencil right there. So I'm going to move the whole thing down 5. So that doesn't affect the vertical asymptote, but it does affect the horizontal one. So I'm just going to do a nice red dotted line there. And I'll do a nice red vertical line right here on the y-axis. There we go. And now I'm just moving the whole thing down 5. So instead of a 4th, it's going to be down here to -4 3/4, and then -4, and then -1, and then the same thing over here because it's going to still be even. So lovely, beautiful graph. And then I'm going to connect the dots. Yep, that's not too bad. Pretty good right there. Excellent. If you got anything different and you don't understand why, please, please, please speak up. Let me know. The domain and the range, I did not move this left or right at all, so the domain is unaffected. It's -infinity to 0, 0 to infinity. The range is affected. Instead of starting at 0, this is going to start at -5 and go to infinity, parentheses on both sides. So one final example. 2 things are happening to this graph. Just as I mentioned a minute ago, my recommendation is don't try to do both things at once. I would do the negative in front of the fraction first, and then the +3 second. I would do this in phases. So first thing though, reproduce the basic graph here, then go through your steps, however they're going to be. Okay, so I've reproduced the basic graph points here in pencil. Two things are happening to this graph. What is first, or what's one of the things? Doesn't matter which one. Okay, it's going up 3. That is true. And then what else?
It's also negative.
The negative. So you're reflecting it. You're multiplying the y values by -1. Okay, so we're doing two things. Multiplying the y values by -1, then we're moving the whole thing up 3. So my advice is to do the multiplying first. Don't try to do both of these things at once. So I'm gonna multiply by -1 first. So just going from right to left here, instead of a positive 1/4, it becomes negative. Instead of +1, it becomes negative. Instead of +4, it becomes negative. And so that's the first part of the graph. I've just reflected the whole thing. I'm drawing it in nice black ink here. Same thing on the other side, positive to negative, positive to negative, positive to negative, and whoop, there it is. All right. Okay, that's my intermediate graph. That's my first step. You guys do really good on the test, letting me know what the final graph is. I haven't had any problems identifying it, so I appreciate that. Then I'm taking the whole thing up 3, so I'm going to move that. Oh, that's terrible. Move that horizontal asymptote up 3, and then here we go, up 3, and then from there up 3, and same thing on the other side. And here's my graph. My final graph is in green. And there we are. That's all I have to say about that. You guys can practice and get good at identifying those